Hi 111. In this video we're going to finish off section 2.4 by talking about what are called piecewise defined functions. So these are going to be functions which are, go figure, defined in pieces, right? Okay, so we're going to have to make use of some new notation here to denote these things because these are a little different than how we've written functions before. So what we do is we make use of this curly bracket thing right here, right? So that we can sort of separate the pieces that are going to be defining this function f. Okay, so it says f of x equals a curly bracket, and then we've got these two pieces. So a characteristic of how piecewise defined functions are defined is that they're going to be one piece for certain values of x and a different piece for other values of x. Okay, so what that means here is that if x is less than 0, we're going to use this piece that says the function f of x is negative x, whatever the graph of that looks like. And for all values of x bigger than or equal to 0, we're going to use the graph of f of x equals x to define that part. So let's try to produce a graph of this thing and see what it would look like. Okay, so what I always do is I start out by just saying, all right, let's start with maybe this, starting out with the negative x values over here, this first line here. Let's just start with the first line, okay? And we say we want the graph to be the graph of negative x. Well, what does negative x look like? Let me get a different color here. Negative x, remember, is the line that passes through the origin like this, right? Yeah? That's y equals negative x, or the function f of x equals negative x. But do I want that whole thing? No, I only want to be that function right there of negative x if my x values are less than 0, right? Okay, so I only want to be on that graph for the part where x's are negative, right? So notice that this part of the x-axis over here, that's all the negative x values. That's when x is less than 0, right? So if my x is less than 0, I want to be on that part of the graph, which means over here on this right side, I don't want to use that part because that's the part of the graph of negative x that's produced for all positive values of x. So I want to get rid of that side. So what I usually do is start out by graphing the whole thing and erasing the part I don't want. Okay? Now, a more important question is, what happens when x is 0? When x is 0, do I want to be on this graph of negative x, on this little piece of negative x? No, because notice that it doesn't say that if you are 0, if x is 0, be on this piece, right? That's not included here. So what that means is I can't use this little part at the origin either, right? I have to sort of leave that part open right there. Okay, so that part's open right there, okay? So that part just defines this part right here. So this is like piece 1. Okay, so this is piece 1. My writing looked really bad right there. So let's see, how do I do this second part? So for the second part now it says if for all values of x that are bigger than or equal to 0, right, I want to be on the graph of what f of x equals x looks like. Okay, so let's do this in a different color. Okay, so what does the graph of y equals or f of x equals x look like? Well, remember that's this line that passes through the origin, right here. And that was terrible. I should do that over. There we go. That's much better. Okay. Now, that's the whole thing. Y equals x or f of x equals x. That's the whole thing. But do I want the whole thing? No, I only want to be on that line x if my x values are positive, for positive inputs, right? Positive inputs or the input of 0. Okay, so I only want, let's see, that's line for when my inputs are positive. So that would be all of these x values over here. Do I want this part down here? No, that's for all negative inputs, right? I don't want any of that stuff over here. Okay, so what I should do is erase the part that I don't want. Erase all this part over here. And now I need to think about what happens at 0 itself, right? If x is equal to 0, I want to be on this line. Well, remember the line passes through the origin, so that means I get to fill in that dot right there. Okay, nice. Okay, well this, and of course this is piece 2, right? So this is piece 2, piece 2. Okay, this is why it's called a piecewise defined function, because the function f of x is made up of these two pieces, right? So the whole graph, the red and the blue, makes up f of x, right? That's the whole graph of f of x here. This may look familiar to you, right? Yes, it is one of our functions from the previous section that we talked about in section 2.3. This is actually the graph of the absolute value of x, remember? So this looks like the graph of the absolute value of x. Yeah, and it is the graph of the absolute value of x. What that means is that this piecewise defined way up here is an alternative way to define the absolute value of x function, right? So you could write absolute value of x, or you could write it defined in this piecewise way here. Okay, so let's just work through one example together and that'll finish off this section. So I'm going to work on example, let's see, problem number 26 from your textbook, number 26. Okay, and this is on page 97. Okay, so the function that we're given is this piecewise defined function here. And there's nothing that says that we have to only have two pieces. You could have more than two pieces if you like. My little squiggly bracket was kind of ugly. There we go, that one's better. Okay, so for this one, it's the piece negative 3x if x is less than negative 1. And it's the piece you are 0 if x is negative 1. And it's the piece 2x squared plus 1 if x is bigger than negative 1. Okay. Well, let's see. What should we start out with here? We should start out with maybe the top one. Let's see. Let's do a graph. So let's do a sketch first. So let's start out with this first piece. So let's graph what negative 3x looks like. I'm going to choose a color. Let's graph negative 3x. So negative 3x is a line, passes through the origin, slope negative 3, right? So maybe something like this. Oops, that was bad. Okay, good. And I want to be on that piece for all values of x less than negative 1. Okay, so where would negative 1 be? It would be like maybe here. Okay, and I would have maybe some kind of a value there, but do I want to be on that piece if I am at negative 1? No, I do not, right? I want to be not included on that section right there. So what that means is I need to erase all of this other stuff down here, and I want to be, oops, eraser. I want to have an open circle right here at the end, because for that piece, for that section, I am not allowed to close it off, right? I'm not allowed to be inclusive at negative 1, right? What would it have been if we were allowed to be at negative 1 there? What would it have been? If x was allowed to be negative 1 here, if x were negative 1 here, that would be what? Negative 3 times negative 1, which is 3. So we know that if we were able to, that filled in circle right there would have been at 3. Okay, but we can't fill it in at 3 because there's not an less than or equals to right here, right? So we have to have an open circle there. Okay? So that's that left piece. I'll mark these by color, right? So this is pink right here. That one's pink. So let's do the next piece. Let's do blue for the next one. Okay, let's do blue for this one. Good. So this says that when x is negative 1, we want the output of the function to be 0. We want to be on the piece that says 0. Okay, well when x is negative 1, that means we want the output of the function to be 0. Doesn't that just mean that we need to fill in this circle right here? That dot right there. That satisfies the blue condition that when x is negative 1, when the input is negative 1, the output is 0. That's what that dot says. And remember that dot right there, that blue dot says f of, when you plug in negative 1, equals 0, right? And that's what this all says right here in that middle line. When this is true, the output is 0. All right, let's handle the last piece. Let's do purple. Purple, good. So this one, you may not know what this looks like. So let's see if we can use our graphing calculator here to get an idea of what this is going to look like here. Let me move some stuff over. Here we go. Okay, so let's see. Let's turn on our calculator and let's get an idea of what this graph right here looks like, and then we can just choose the piece of it for which x is bigger than negative 1. Okay, so let's store it into our y equals 2x squared plus 1. And let's hit graph. Ooh, nice. Okay, so it looks like it's a parabola, right? And let's trace on it so we can see what its features are, right? It looks like its y-intercept is 1, and then it sort of goes up in either direction, right? So let's make a little sketch of that whole thing, and then maybe we'll just erase the part that we don't want. Oops. I don't want to be all the way up there above 3. My y-intercept needs to be 1. It needs to be down here. 1. And then on either side, I go up in either side. Now, let's think for a second. Do I want to draw the whole left part of this parabola to go up this direction, or are there already pieces there? There's already pieces there, and it says you want to be the parabola shape only for values of x bigger than negative 1. Okay, so what would the value of this piece have been if you were allowed to be at -1? We can't actually include it, but where would we have been? Well, let's use our calculator to figure that out. Remember that when we're in the trace mode, we can enter a value of x that we'd like to jump to on our graph, and it'll tell us where we would have been, right? So we would have been at -1, 3. Oh, well, let's see where -1, 3 is. -1, 3. Oh, that's the open circle right there, right? So we would have been right there if the parabola were allowed to be including in the if we were allowed to use -1 for that parabola, right? But we're not allowed to be at that point. We're allowed to just be like right next to it. So what that means is we continue this parabola all the way to that open circle. Okay, so we continue that little section right there. Okay, so we're allowed to be what? The parabola for values of x, -1, but not including -1, and bigger, right? So all of these values of x, right? This direction, okay? -1 and bigger, but not including at -1. At -1, we are at 0. That's the blue dot. And then for the red one here, remember the red one said we are on this line for all values of x, -1 and smaller, right? So all the x's that direction are on this piece. All the x's -1 and bigger are on the parabola. And at -1, we are that blue dot. Okay, and this is a piecewise defined function. Okay, it's got some kind of crazy pieces, right? So let's erase some of this extra stuff so that we can just get a really clear picture of what the graph itself looks like. Okay, so the last thing we want to do is to just get some values of the function. So for example, if I wanted to find f of -2, right? This is saying what's the value of the function when the input is -2? Well, just determine which interval of x's this falls in and use that piece to calculate the output. F of -2 graphically would have been where? Would have been right here, right? On the line? Well, that's because -2 is in this interval, the first one. So we should use this rule of -3x to calculate the output. Okay, so we should use -3 times the input, which is -2. So this is 6. And we know that this output right here, that would have a height of 6, right? -2 gives 6. Alternatively, we could do something like f of -1. We already know that. That's the dot, right? F of -1 is 0. And for this last part of 26, what about f of 0? F of 0. So what is the function doing when the input is 0? 0 is, where would that be on the graph? That would be the little y-intercept right there, right? Well, 0 is in this interval of being bigger than -1, so we should use the parabola as the rule to calculate the output of the function. So we do 2 times 0 squared plus 1, which is 0. This is 0, right? Plus 1. 1. So that means here, that's that dot right there, right? The y-intercept. Okay, we'll talk more about piecewise defined functions in class together tomorrow.